This conference will now be recorded.
Yeah, very good morning to everyone. So in the last session, like we started with one statement, right? What statement we talked about? Generate statement using gen variable, correct? So what is the use of this generate statement? Generate statement is used to generating the instances, right? So you can use generate statements in modules, correct? User-defined primitives, it is used in gates, it is used in continuous assignment statement, used in procedural blocks like initial and always block. It is used to generating the instances. So after that, we started discussing about some of problems, questions on behavioral model, correct? Behavioral model. So let us continue with this today, and then we go with the task and functions. What is a task and function? What is the use of this task and function? Okay. There is a one issue with this, right? We were talking about this one. So this is nothing but what blocks it is. The question is talking about what is the final result, right? What is the final result of this execution, correct? This execution for the blocking and non-blocking. We understand that how this blocking works, and we understand what is the final result of A, B, C, D, correct? In terms of blocking. Now, if it is a non-blocking statement, what is the output of this is? Non-blocking. What is the output of this? So the non-blocking works is nothing but it is a two mode of operation. One is read mode, another one is write mode. At time t is equal to 0, all your right hand side should be evaluated, and that should be read into the local variables in the simulator, and then that will be assigned to the left hand side. The relative to the what? The time, simulation time, what we have mentioned to the state. So that is all are executing at time t is equal to 0, correct? At time t is equal to 0, can you tell me what is the value of A, what is the value of B, what is the value of C, and what is the value of D? A is equal to 0, at time t is equal to 0. What is B is? X. C is nothing but what? X. What is D is nothing but? So D is a 3-bit now, right? It is concatenation of A, B, C. I can write D is what? X, X, X. Then at what time next it will be executed? Huh? T is equal to 5. At T is equal to 5, what is the A value? What is the B value? What is C value? What is D value? X, X, X. Correct? Then what is next time the non-blocking will start executing? At time t is equal to 10. What is A value? B value? C value? What is D value? X, X, X. Correct. Then what is the next time is? What is the next time? At time t 20. At time 20, what is the A, B, C, D value is? A is 0. B is 1. C 0. What is D value? What is D value? D value should be X, X, X because these are non-blocking statements. Correct? If you use $symbol monitor to monitor this, at time t is equal to 10, what is the values? A 0, B 1, C 0, D is nothing but what? No, unknown, X, X, X. If I am using $symbol monitor, how the $symbol monitor will work? Where their input signal values are changes, then only it will monitor. When it is coming to time t is equal to 20, these values are not changes, right? That's why it is not monitored. Did you understand? At time t is equal to 20, d is nothing but what? X. Is it clear? Non-blocking. Are you understand this? So yesterday why it is only printing t is equal to 5, t is equal to 0, t is equal to 5 and t is equal to 10. Because it is a non-blocking, values are not changes after this time stamp. So that this monitors up to here. Did you understand this blocking and non-blocking operation? Now let us continue with the questions. Now let us continue with the question. I think this question this is what? Correct. We saw the output of the non-blocking state. I mean, this question we have done, and all these are done. D flip-flop with synchronous clear, asynchronous clear is done. Then this asynchronous multiplexer is done. Correct. Then case statement using ALU design, 8 function ALU using what? Case statement. This is we have done. Now let us, I think this is also done. So use while loop, design a clock generator, initial value of the clock is 0. So while with what condition you can put? 1. Infinite loop. While with the infinite loop, the condition as long as true, that loop will be keep continuous. Correct. So this is similar to equivalent to what? Forever loop. Correct. This I think we have done already. So I'll make an array of what? Depth of 0 to 1023 and then size of 4 bit, assigning the 0 value to all the locations. Correct? Whether we have done this? Can you write a program to this? Using forever statement, design a clock period with the 10. Design a clock period with the 10. And duty cycle of 40% duty cycle. Initial value of the clock is 0. Initial value of the clock is 0. Can you write a program to this? What loop they are asking to do? For clock period of 10. But duty cycle of how much? 40%. So duty cycle 40% means what? T on should be?
मैं जा पढ़ने बैठ भाई.
T on should be 60 or 40. T on should be 40 and T off should be how much? 60. Correct? 100% duty cycle means 40% duty cycle means T on should be 40 and T off should be 60. So you know that what is the duty cycle formula, right? Duty cycle is equal to maximum number of T ons divided by total time period. So here you have given the total time period and then duty cycle. So we should find out how much time you should make a T on and how much time you should make T off. Correct? So what should be the T off time should be? 6. What should be the T on time should be? 4. Correct. And how to write a program to this? Using forever loop. Forever loop. So let us start with what? Module. Correct. Let us take module TB, clock generation. Then clock. Declare as a reg data type. Then is any other variable is required to clock generation? No. Then I need to generate the clock. So forever they are asking, so that I should use inside the what? Initial begin. So in the initial begin, this is initial and end to the initial. Now initial begin, what I need to do first? Initialize clock to 0. Correct. Initialize clock to 0. Again, what I need to do? Forever. If it is a multi statements, begin and end, then what I need to do? Dash 5 or 6. T off should be what? Dash 6, right? Let us calculate this. Calculate the duty cycle of this. What is TP as given? 10. What is the duty cycle? 40% means how much it is? 0.240. Correct? Then duty cycle is equal to what? T on divided by TP. Or this I can write T on divided by what? T on plus T on. Now this is 0.44, correct? Into what? 10 is equal to what? T on. Then what is the T on value is nothing but 4. Then you know that TP is equal to what? T on plus T off. So I need to find out the T off. T off is equal to what? TP minus T on. So TP is what? 10 minus 4 is equal to what? 6. You don't understand? Now T off should be what? What is the T off should be? 6 and T on should be what? 4. Then how to write using forever loop? As 6, I can make clock is equal to what? Not of clock. Or clock is equal to 1. I should make this is equal to clock is equal to 1. Then ash 4 is equal to what? Clock is equal to 0. Then end the what? Forever. Then I'm ending the initial begin. Then what I need to do? End the no, then I need to monitor this. So let us go with what? Initial begin dollar symbol monitor of what? Time, simulation time, current simulation time, then tab space, clock is equal to what? Percentage B. What argument I need to pass? Clock. Right. Then let me give the finish time 500 and dollar symbol finish. Then what I need to do? End the module. Now let us generate the clock. This is the clock generation. Let us copy this result here to analyze. At time t is equal to clock 0. Okay, 0 to 1 means what? T off, right? T off should be 0 to 6 means what? Now 6 at clock is 1. 10 at clock is 0 means what? T off should be T off 6 and T on should be 4. We don't understand this. How to generate the clock using what loop we are using? Forever loop. With the duty cycle of 40% and time period 10. So this is the one. Let us copy this. Let us go to the next question. The next question, using a repeat loop, delay the statement is equal to what? A is equal to A plus 1. A is equal to A plus 1 is nothing but increment of A, correct? So I need to delay the statement that A is equal to A plus 1 by how many cycles? 20 positive edge of the clock. 20 positive edge of the clock. So can you think and write a program to this? What loop they are asking? What is the repeat loop? What is the repeat loop? It is going to iterate at the fixed number of iteration. Fixed number of times it is going to do the iteration. Can you analyze the program to this? It's talking about using repeat loop, delay the statement. What statement is? Delay the statement A is equal to A plus 1 by 20 positive cycles. So what it means that, and every 20 positive cycles, A should get increment. Correct. That is what the statement is. That A is equal to what? A plus 1. At every 20 positive edge of the clock, A should get incremented. How to do this? What we need to do for this program? Initial value A is equal to 0. Always, correct. Always positive edge of the clock. Generate the clock. Because clock is required here. It's talking about after by 20 positive edge of the clock cycle, this statement should exist. How to do? How to write a program to this? How to write a program? Module, TB. We need an integer, right? A is an integer. Let us take A is an integer. A is equal to A plus 1 is talking. Integer A. Then we need to generate the clock. So let us generate the clock. It's not talking about what time period it is. Let us generate the clock using always clock. Always hash file. Clock is equal to what? Not of clock. Okay, this is fine. Then what we need to do? Initial begin. Initial begin. So let us initialize A to what? 0. What loop we need to use? Repeat. What is talking about? Repeat of how much? 20 times begin. What we need to do? Is it A is equal to? He's talking about 20 positive edges. 20 positive edges is talking about. To understand this question properly. So repeat loop, delay the statement. I need to delay the statement. What statement? A is equal to A plus 1 by how many positive cycles? 20 positive cycles. How to do this? I need to delay by this how much? 20 positive cycles. So this is used to generate the clock. And initial begin, I am initializing initially A is equal to 0. Repeat loop, this is begin and end. Begin and end. And this end for this initial, what I need to write? I need to write the event here. What is event is? At the rate cos edge of what? Clock. What I want to do? A is equal to A. Then what statement I need to write? A is equal to A plus. A is equal to A plus. Did you understand? So what we are doing is nothing but we are delaying the statement. A is equal to A plus 1 by how many positive cycles? This repeat loop will repeats, correct? It has to repeat at what edge? After delay of what? 20 positive edge of the clock. Did you understand? This will be delayed by. Now what I am writing the event is nothing but at the rate of pass edge of the clock, what I am doing? Assigning A is equal to A. And next to 20 cycles, what happens? This statement. A is equal to A plus 1. Delayed. And A is equal to A plus 1 for the next 20 positive cycles. Again, next 20 positive cycles, again what? A is equal to A plus 1. Okay, let me monitor and show you the output. Initial begin. Initial begin. What I want to do? Let us monitor this. Monitor of what? Dollar symbol time. What I want to monitor? A. A is equal to percentage 0D. What argument I need to pass is A. So let me give 500 finish time. Then end the module. in the morning. Did you understand? As run this for the syntax error. So we need to declare the clock, right? Reg clock. So we need to initialize the clock here also, correct? I'm using clock, but I was not declaring that. Okay, now I declare the clock and initialize the clock. This is a mistake is so dollar symbol finish. This is FINISH finish. But this is not delayed for what? 20 clock cycles, right? Initial at time t is equal to 0 and every positive edge clock comes. Now this is working at this program basically working at every positive edge of the clock. What happens? Assigning. So at the positive edge comes at what? 5. Now A is incremented to 1. At 15, what happens? A is equal to 2. Again at 25, A is equal to 3. All the positive edge of. But it is not delayed by how many cycles? 20. But my question is what? I want to delay the statement. A is equal to A plus 1. Delay by how many positive edge of the clock? 20 positive edge of the clock. So can you think of this problem? Now this is generating at every positive edge of the clock. Statement will be executed. A is equal to A plus 1 incremented. Write a program to this. What could be the mistake? So we are writing always at the positive edge of the clock. So we are using repeat. 20 positive edge of the clock, A is equal to A. And this should be correct, right? Asha? This is hash of 10. So time period, that what is hash 10 indicates that the total time period is what? Time period is 20. So now at time t is equal to 0, A is 0. So the positive edge comes at what cycle? What time period? T is equal to 10. And next positive edge comes where? At t is equal to 30, right? At t is equal to 30. What is we are assigning the value, delayed the value by what? How many positive edge cycle? 20. Now this is working fine. You can see here at t is equal to 0, at t is equal to 10, rising edge comes. Now I am writing the program for what? Whenever positive edge of the clock comes. Positive edge of the clock comes. Now this statement is executed. What? A is equal to A plus 1. Now this is delayed by how much? 20 positive edge of the clock. Then what happens? So next edge comes at where? Next edge comes at 30. At 30 it becomes what? 2. So this is a question. We need to 20 positive edge of the 20 positive edge. 20 positive edge means it is a time period. If this is a time period, 20 different positive edges. But whatever output we are getting is this is not this is delayed by how much? One total time period. 20 time period it is delayed. But this is not a correct one, right? So let us see this one. This is one clock, reg clock, initial begin. A0 clock 0, we have generated the clock. Here we have generated the clock using what? forever. So we are monitoring this. Then always at the positive edge of the clock. Okay, one mistake I have done is nothing but I should do at one. Always at the positive edge instead of one. Initial begin. Then I can go with one. Repeat 20 positive edge of the clock, A is equal to A, then A is infinite. So what I need to do here is nothing but let us end this here. Okay. Now what I need to do? Always at the cos edge of the clock. Cos edge of the clock. Correct. Then begin, and then end. Begin and end. Now this will repeat after every 20 cycles. Let us give the more delay here. 1000 finish. Now let us run this. Now you can see this is working now. Initial at time t is equal to 0, A is equal to 0. When the positive edge comes, what is the time period we are given is 10. That a positive edge comes at 30. 30, then when the output is changing, 30, 50 minus 30 means how much it is? 20. So I think that this should be 20 time period, not the 20 positive edges. Correct. 20 time positive edge of the clock. I want to generate. Okay. So this is a question of 20 means okay. The point is here it is 30. Then 20 positive edges for 30 means 1. Where it comes next 20 positive edges means 1. Huh? Is it 50? So at time t is equal to 0, A is 0. Then next it will delay by how many clock cycles according to the problem is 20. 20 means at time t is equal to 0, how many clock pulses? How many positive edges? So what I mean to say, this is a program is asking about this one. At time t is equal to 0, what is A is equal to 0. Then next what? How many clock cycles? 20 clock cycles. Correct. So this is my clock. If I am going to write the clock like this, I need to delay this by 20 positive cycles of the clock. Suppose this is a rising edge of the clock, time t is equal to 0, A is equal to 0. So then when I need to make t is equal to A is equal to A plus 1, after 20 positive cycles. So this is 1, 2, so on, up to so on what? 20. At the 20 what I want to do? A is equal to 1. And the next to 20 cycles, A is equal to 2. Next to 20 cycles. This will be delayed by the 20 positive edges of the clock.
खाने के बाद है ना साला कुतरा दिमाग को खराब करेगा इतना तुम सब्जी रहे इधर के देखिए और इतना तुम लाइट गई भाई लाइट गई इतना खाने में होशियार है इतना तुम सब्जी रहे इधर के बाप रे बाप हनुमान जी है ये तो रे
खत्म हो गया क्या साला
सब्जी रह दिल के देखी हाँ छाछ भी देने 2 कटोरा पी के भाई हनुमान है खाए में अब पानी नहीं डालने पानी नहीं है कैसा के गरमा कर ले अब है लेके आगे को थी मेरे इतना खाने है वो क्या है अब काई जरी सा लेके कितना सब्जी से पूरा पगला यार कुछ के मारे हो जाइए सही
conference will now be recorded.
Is it 410? Now we are getting this 410. After at the 410 we are assigning this a is equal to 1. Then next where I need to do?
चुप रहो यार
After 20 positive edge of the class.
पूरा खा ले दिया
After 20 means what? 830. 820 or 830? Okay, let us increase further. Let me make this into 5000. 5000 finished and then I'm going to. How can you see this?
ये क्या बात होती है भाई ये क्या बात होती
Okay,
है
let us do one thing. Instead of making this into 20, let us make this into 5. What it means? After delay 5 positive of the clock, then I need to assign this. A is equal to A plus 1 be delayed by 5 cycles, 5 positive cycles. So at t is equal to 0, and then 5 delays means how much? 110. At 110, E is equal to 1. Next is next after 5 means what? 5 positive cycles means what? Is nothing but 230. Did you understand? Are you clear this? Okay, let us do one thing. Let me run this using model sim and we'll verify with the timing dial. Let's make the folder. Let us make tb.v file. Let me copy the run.do file somewhere. So this I need to change into what? The file name I was given is pb.v. Then this is correct. Then I'm going to save this as run.do file. Then save all.
हम लोग कहता है हम शाम को मिठाई रोटी हो जाएगा बस हम सब्जी नहीं खाएंगे शाम को बस बोलो
Let us see the waveform.
बोलो बोलो गाड़ी अपनी तरह है हम लेते हैं वो आता है कहाँ में हम ले ली और बोला है
I'm giving clock of delay of how much? 5. Correct. After 5 positive edge of the clock, what I want to do? This is at time t is equal to 0, right? So this is a rising edge comes here. This is 1 cycle. 1, 2, 3, 4. Correct. This is 4, 5. Please delay how much? 5 positive cycles. Now what we are doing? A is equal to A plus 1 incrementing. Again at the next how many cycles? 1, 2, this is 2, 3, 4. From here to here it is 1, right? 1, 2. Again this is 3, 4. Again at 5. At this we need to make what? Increment assigning A is equal to what? A plus 1. But after this, what happening here? This is changing at what cycles? 6 positive cycles. Can you see the program what I need to do? Did you understand? Okay, let us That is shown next one. So this is changing at what? After 5 positive clock cycles. Now let us check the next one. This is also 1, 2, 3, 4, 5. This is also changing at what cycle? 6 cycles. Can you see what is the mistake in this program? Very first one is fine. It is delaying how many clock cycles? 5 clock cycles. But after this, again, next it is delaying how many cycles? 6 cycles. Can you think of this? How to address this problem? I want to delay by how many cycles? Let us consider 5 cycles I want to delay. You see what is the mistakes we have done in this program. Can you see this always block? How this always block works here? Time t is equal to 0, clock is 0, and then rising age will come at what time? Total time period of this is nothing but t off should be 10 and t on should be 10. So that the rising age comes at where? 10. Correct. So whenever the rising age comes, so we are using the repeat statement. So we are repeating what? Repeat of 5 times. I want to repeat this. So at this positive edge of the clock, we are assigning A is equal to A. Whether I want to assign this positive edge of the clock A is equal to A after this end or inside this repeat loop.